Now let's talk more about exceptions. We have seen this try block and a catch block. The catch block is also known as the exception handler. Now in this example, we are catching an exception object. Alright, this is the uh, exception handler for the exception object. So a few questions here. Number one, what is this? And number two, what is E? It does not have to be E. You can catch exception X, catch exception A, although by convention it's usually E or EX. There's no good reason for you to use any other variable name. Okay, to answer the first question, this is a type. Now realize that exception starts with a capital letter. That probably gives you a clue as to what is it. Alright, in Java, class names and interface names start with an uppercase letter. Now let's look at the API documentation. Okay, this is for version 7. You realize that there is actually a class called exception. Here it is. This is a very important class of the package java.length. And like normal classes, the exception class has got constructors. Okay, a constructor which takes in nothing and a constructor which takes in a string. So these are the two most frequently used constructors. The other overloaded constructors, as you can see here. And of course, there are several methods which are inherited from the superclass which is called throwable. Now the one which you will probably use a lot will be getMessage. Here it is. So getMessage has been inherited to exception, and when you call getMessage of an instance of exception, it returns a string, okay, which is basically the message embedded in the exception. Okay, remember I was saying an exception object represents an error condition, and an error condition can embed a message to describe the error condition. So realize that we saw the number format exception just now. Okay, here it is, number format exception. Same thing, a number format exception is a class. Alright, and you realize that somewhere up there in a class hierarchy is exception. So number format exception extends illegal argument exception, which extends a runtime exception, which extends java.length.exception. Hence, you inherit all the important methods such as getMessage. And number format exception has a constructor which takes in nothing, as well as a constructor which takes in a string. Now this string passed in is actually the message which you can retrieve later by calling the getMessage method. So back to our question. Alright, what exactly is E? Okay, what exactly is E here? Now, E is a local variable, okay, which means that you can only make use of E from this opening curly brace to this closing curly brace. Okay, you can't use E outside the catch block, outside this particular catch block. E is a local variable which stores the address of the exception object caught by the catch block. Okay, let me say again. Okay, when we run statements, okay, let's assume this statement runs. This statement causes an exception. So an exception object is actually created here and thrown and caught here. So E will store the address of the exception object. In a catch block, you can do anything you want with E, including you can do stuff like system.println. Alright, e.getMessage. Okay, as you can recall, getMessage is actually a method inherited from throwable. Alright, so it is found in the exception object, which is stored in E. So this will print out the message, okay, which should describe the error condition. Now another useful method usually used for debugging, okay, of the exception object is print stack trace. Okay, I'm looking at exception here. Okay, print stack trace. I saw it just now. Here it is. Right, print stack trace returns nothing, but basically it prints something to the console. So print stack trace is commonly used for debugging purposes only. Alright, it is usually not used in a production code because you may not even be sure that, oops, let me get rid of my emails. Okay, I was saying that in production code, you may not even know if this is a console application. It may be a GUI application, which does not show a console, and the stack trace will predict the console. Okay, and who will be looking at the stack trace. So it's usually used for debugging purposes during development in the development phase. You can call the print stack trace method of the exception object. This will print to the console the stack trace. And what exactly is a stack trace? We will take a look at it very soon. Okay, another concept which I want to discuss with you guys is that you can have multiple catch blocks. Okay, you can do stuff like this. Instead of having only one catch block which catches one particular type of exception, we can have, in this example, you see one try block is associated with 3 catch blocks. The first catch block catches a number format exception. Alright, so if any statement in the try block causes a number format exception, this is the correct exception handler. The second catch block catches a runtime exception, and the third catch block catches an exception. So of these 3 catch blocks, if an exception occurs in a try block, only one of the 3 catch blocks will execute. Alright, never 2. Only one of the 3 catch blocks here will execute. Right, depending on the type of exception caught. Now there's one rule here. If you have multiple catch blocks, okay, if you look on the right here, okay, on the right I've shown you the relationships between the different exception classes. The exception class is the parent, alright, of runtime exception. And runtime exception is the parent of illegal argument exception, which is the parent of number format exception. Now, all these are documented. If you look at the documentation again, and let's take a look at number format exception. Oops, why am I scrolling up when I should be scrolling down? Number format exception here. Okay, the documentation shows you the inheritance tree. Number format exception extends illegal argument exception, which extends runtime exception, which extends exception. That's what I'm trying to show on the right side of the screen here. Now, what is the significance? The significance here is this rule. If you have multiple catch blocks associated with one try block, the sequence of the catch blocks matter. Okay, in other words, these 3 catch blocks cannot be swapped. Now, if I try to swap them, for example, okay, let me change this and this. Alright, so here I catch exception. Here I catch number format exception. Now if you try to write code like that, you get a compilation error. Compiler will complain. And why is that the case? Now, when statements in the try block run, okay, they run in sequence, right? Let's say an exception occurs here. And let's assume that this exception is a number format exception. Now, which happens when you try to call integer.parseIn and pass in ABC instead of 1, 2, 3, and it causes a number format exception. So all the subsequent statements in the try block will not run, and the runtime engine will try to match which is the correct catch block for the number format exception. You will try to match the first catch block first, and there's a problem because if you remember the is-a relationship, a number format exception is an exception according to my inheritance tree at the right, which means that all exceptions, regardless of whether it's a runtime exception, illegal argument exception or number format exception, if they are thrown in the try block, will all be caught in this first exception handler or the first catch block. Now, which renders the subsequent two catch blocks useless. So this kind of code will not compile. Alright, so what should happen is, undo all this stuff. What should happen is that if you have multiple catch blocks, they must be sequenced such that um, the child exception classes are on top. Let me say again, the child exception classes are on top. So in this case, I'm catching three types of exceptions: number format, runtime, and exception. There must be in this sequence. Number format exception should be the first catch block, followed by runtime exception, followed by exception. Okay, in this case, I'm not interested in the illegal argument exception. Alright, if you try to swap them around, you can't even compile the code, which makes sense, like what I've explained just now. Okay. On the other hand, if you have multiple catch blocks and you're dealing with unrelated exception types, for example, let's say if you have another exception here, which is called ABC exception, for lack of a better name, and you're trying to catch illegal argument exception and ABC exception, it doesn't matter. Their sequence do not matter. All right, if you have these kind of situations. But if you have a parental-child relationship, they must be in the correct order. Okay, I'll stop for now. Okay, I'll move on. In the next section, I'm going to talk about using the finally keyword.